Today we go with the different type of methods to draw a geometry. Okay, who's that? Okay, symmetrical and non-symmetrical beams. Now, what you mean by symmetrical? Symmetrical means a unique dimensions, and non-symmetrical is a different type of dimensions. And you know already some copy paste method, I think so. Now you know the procedure, and already you done the some of the projects also. So like this, you know these procedures, but here you can observe all the span is same. Okay, means uniform or symmetrical. It's a 6 meters of span. This is for 5 meters of span, and also this is for 3 meters of span, and this is for 4 meters. And we complete the all type of loads: uniformly distributed load, linear varying load, concentrated force, and partially distributed loads also. Okay, these all are the unique and symmetrical question. Now we go with the non-symmetrical question. Means, for example, 6.23, 5.2, 3.1, for example, like that. Because in our every question we can consider as a AutoCAD plan. Okay, so depending on the AutoCAD plan, we go with the this analysis part. And in our AutoCAD plan, mainly used in feet and inches. For example, I have column to column distance in feet. 10 feet equal to how many meters? Now here you can observe 10 feet equal to 3.048 meters. Of course, we can round figure it as a 3.05 meters. Okay. In this condition, you can observe no, it's not possible. Ten feet equal to how many meters means 3.05. We can round figure as a 0. And previous questions all are in 3, 4, 5, 6 something, but in our AutoCAD plan mainly used feet and inches. So those feet and inches we converted into meters, and that particular beam or building we can analyze the model. In that purpose, I will explain that 3 different type of methods. First, commonly you can open your software. Now, in this geometry box, we have a 3 type of methods. One is coordinate system, second one is copy paste method, and third one is translational repeat. Okay, we have a 3 procedures. Now, these 3 procedures are geometry only. Means step one procedure only. These 3 steps. Now, I go with the coordinate method. In this coordinate method, we don't need this grid. Okay, we don't need this grid. Now, how to skip this grid? Simply escape, and in right side we have a snap and node beam box. Close it. Now grid will be hided. Okay, it's not deleted, it's just a hide. Now, if you want grid again, simply go with the left hand side geometry. You can get the grid again. And your right side, snap and node beam box also. When you close the snap and node beam box, grid also deleted. Now observe, here we have the 2 boxes, right side. Okay, I think it is visible. In right side, you can observe structural nodes and structural beams. Beam means already drawn part, so we need a node point. Now I consider 0 node. Okay, this is my node because every single beam have a 2 node points. So in that purpose, I selected here 1 node. Now second node, I consider 3.05 meters in X direction. Now right side you can observe node 1, 2. First node x, y, z all are 0. Second node x 3.05, y 0, z 0. Now in single axis beam I draw, but I don't have the beam here. We have only 2 node points. So to join the beam, procedure is go to menu bar, geometry, add beam from point to point. First point to second point. Now you draw a beam. And also I want to check my dimensions. Select the beam. Here in this above, we have a dimension symbol. Okay. I hope you know already AutoCAD. So same symbol, AutoCAD symbol only, dimensional symbol. Now click on display. Now my dimension is perfect. But when you're using grid method, we don't have the decimal numbers. Okay. No decimal. We have only round figure 3, 4, 5 like that. But in this coordinate method, we can go through the like these decimals also, point values also. Same thing, I want to continue another beam 3.2. Okay. Now, sorry, 4.2. I consider as a 4.2. Now imagine here we have a grid point. Already first point is 0. Second point is 3.05. And third point I need 4.2. Right? Now, where it is? 4.2. Now I got it. Now go to geometry, add beam from point to point. Like this you can prepare your beam, but you can observe this beam is very long, this beam is very short. Okay, compare here, my first beam is 3.05, my second beam is 4.2, but these two are different. Once you can check the dimension, what will happen here? First beam 3.05, second beam 1.15. But in my point of view, second beam I consider 4.2. But coordinate system, they don't accept the last point. They accept only the first point. It means first node point 0.2. You can calculate or adding the points. Now, if you need it 4.2 means here you can enter 7 point. So what? 7. I don't type over. 7.25. Okay. In this coordinate system like this, we can prepare our beams or step number 1. And some of the cases it is difficult to you because we go with the large structures or high range structures, high range structures. In that time, it is little bit hard. So that is the reason we have a more 2 types. Anyway, first write down this method. Write down this method. Copy paste method. Sorry, coordinate method. Side heading, coordinate method. Side heading, coordinate method. Okay. Total procedure is same, only geometry is different. Side heading,